Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about functions as power series. So basically we're going to try to get into the heart of the matter now. What we want to do is we want to take functions and write them as a series. So we want to take functions that we're used to seeing every day, ordinary functions, and write them as series. Okay? And then we can talk more about them. All right, so let's get started on working with this. So it's actually easier than you think it might be. So again, the goal is to take a function. So again, what are we talking about in terms of a function? We could be talking about anything. We could be talking about f of x equals x squared, or f of x equals 1 over 1 minus x, which is the one we're going to be talking about here in this video. And we want to write it as a power series. So we want to convert this function into a series. All right. And the way we're going to do that is we're going to use the concept of a geometric series. So we know that the sum from n equals 0 to infinity of a times r to the n is geometric. And its sum is equal to a over 1 minus r as long as the series converges, right? And that series will be convergent if r happens to be a number between -1 and 1, or the absolute value of r is less than 1. Okay? So here's what we're going to do. Let's suppose that a in my sum formula, a equals 1 over, or a equals, s equals a over 1 minus r, is equal to 1, and r is equal to x. Then if I substitute a equals 1 and r equals x into my a over 1 minus, or a times r to the n equation, I would get 1 times x to the n. So the sum from n equals 0 to infinity of x to the n, well, now if I take a equals 1 and r equals x and substitute them into this sum formula, I would get s equals a over 1 minus r would become, if a is 1 and r is x, then a is 1, r is x, then I get 1 over 1 minus x. This is a function, 1 over 1 minus x. Okay, for the absolute value of x has to be less than 1. Now, what does that mean for the absolute value of x is less than 1? Well, that means x has to be between 1 and -1, right? And there's your interval of convergence. So I would be -1 to 1, open on both ends. Okay, open on both ends because a geometric series does not converge when when r equals 1, right? R has to be less than 1 for it to converge. Okay, so that means that this function, f of x equals 1 over 1 minus x, can be represented by this series, the sum from n equals 0 to infinity of x to the n. And that's the goal behind today's video, is to take functions and put them in the form of a over 1 minus r, because a over 1 minus r leads me to the sum of a times r to the n, leads me to that geometric series, which I can then take a function written in this form and convert it to a series. Okay, that's what we're going to try to accomplish. All right, so let's take a look. So let's try to find the power series representation and interval of convergence for f of x equals 1 over 1 plus x cubed. All right, so again, the goal is to get this function in this form, a over 1 minus r, because then I can convert that to a sum of a times r to the n power. All right, so basically what I need to do is the following. The two main things you need to accomplish is, first things first, this number here in the denominator needs to be a 1. That sign there needs to be a negative. And then this is going to be your variable term, and there's going to be a numeric constant up here in the numerator. Okay, so we can do this one pretty easily. We can convert this by writing 1 over, the 1's already there. Instead of writing plus x cubed, we're going to write minus negative x cubed, because that's the same thing as that, right? So we can't change the actual function itself. All we can do is change the look of the function to put it in this form. So now we're in this form, a over 1 minus r. That means a is equal to 1 and r is equal to negative x cubed. So I can take this and substitute it in here. So then this is going to give me the sum of 1 times negative x cubed to the n power, which I can rewrite as 1 times, this is going to be negative 1 to the n times x to the 3n, right? Take a look, think about it. Again, this is negative 1 times x cubed to the n power. I can distribute the n power to both, and I'd get this alternating series now, negative 1 to the n, x to the 3n. And that's my series. It's the sum of negative 1 to the n, x to the 3n. Okay, now remember, the absolute value of r for this thing to converge has to be less than 1. We want to find that interval of convergence. Well, r is negative x cubed. So negative x cubed has to be less than 1. So the negative really doesn't matter because it's absolute value. So this is the absolute value of x cubed has to be less than 1, which I can then create. X cubed has to be less than 1, has to be greater than negative 1. Cube root everybody. Right? Cube root x cubed. Cube root of 1 gives me negative 1 less than x less than 1. So my interval of convergence for this series is open, negative 1, 1, open. Okay? And again, it has to be less than 1 here no matter what, because the geometric series only converges when the absolute value of r is less than 1. This is my answer. This is the series for that function, and this is the interval of the convergence. Okay? The function and the series are interchangeable from each other. You can go back and forth. Instead of writing the function, you can write the series. All right? They mean the same thing. That is extremely important here in the second half of this chapter. Okay, let's try another one. Let's try 1 over 5 minus x. All right, so again, we're trying to get a over 1 minus r. We have the subtraction sign. The problem is this number is not a 1. It's a 5. So what we're going to do is we're going to divide the numerator and denominator by 5. Okay? So now I'm going to clean this up a little bit. It gives me 1/5, 1 minus x over 5, right? So now I'm in the right form. A will be 1/5. R is x over 5. So I'm going to write this as the sum, a times r to the n, which is going to be the sum of 1/5 x over 5 to the n power. All right, so now we're going to do a little bit of manipulation here so that we kind of clean it up a little bit. Sometimes you have to do this, sometimes you don't. So that's 1 over 5 times x to the n over 5 to the n. So that's the sum of x to the n over 5 to the n plus 1. Okay, that would be my sum there. All right, now I need the interval of convergence. So to find I, the absolute value of r has to be less than 1, which means that the absolute value of x has to be less than 5, which means that x would have to be between 5 and negative 5 if I solve it. So the interval of convergence is open, negative 5, 5, open. So there's my series. Okay, and again, we can put labels on this, n equals 0 to infinity. If you want, it's an infinite series. And again, the idea is the fact that this function and this series are interchangeable. It doesn't matter which one you use because they mean the same thing. Okay? And that's it for this lesson. All right, we're just converting functions as best we can into this form, a over 1 minus r, and then writing their interval of convergence based on that geometric series. As always, thanks for clicking.